All right, guys, happy Friday. I'm actually right now really thankful that I didn't go ahead and do the Friday video early, because I usually just do them all in one day. Because getting your comments has actually been very helpful in what you see and what you don't see, what you're getting, what you're not getting, what you're good at, maybe what you're not good at. So I think right now, the only thing I haven't heard about is the quadratic equation. I think we're all good on that way, so I'm not going to talk really about the quadratic equation today. You have it. Once you know the formula, you can use it. But I want to talk about the other ways. So we're just going to do a few more problems. We're going to start with a completing the square. Okay. When you're completing the square, the big issue is, and I didn't say this the other day, and I apologize, is that the x squared must be by itself. Okay? So if you have something like 3x squared minus 6x plus 5 equals 0 or equals y, you can't complete the square with that b and that a being there. The a, the number in front of the x squared, has to be 1. Okay? So, few ways to do this. I personally am going to subtract 5 from both sides. Oh, wait, no, that 5 is the subtraction sign. Sorry. It's helpful if I write it down correctly. That's a subtraction sign. Why am I in blue? Subtraction sign. So, the first thing I'm going to do is to add 5 to both sides. It really doesn't matter that greatly, but it's up to you which order that you go in. Equals 5. Okay, and now we have to get the x squared by itself. Okay, so how do we get x squared by itself? We're going to divide by 3. Well, if we divide one piece by 3, what do we have to do to the rest of it? Okay, I'm just going to completing the square. Okay, so now that we divide everything by 3, I'm going to scroll just a little bit. We have x squared by itself. X squared minus 2x, and I'm going to go ahead and leave my blank there, equals 5/3. And it's okay that that's not just a perfect number. Okay, and then we'll put a little plus and I'll put a blank out there because I'm completing the square, and that's what we're going to do. Because we want what's on the left of the equal sign over here with this 2x now to be a perfect square. Okay, you have to remember the fraction, b over 2. Okay, if we want it to be a perfect square, we're going to square that. Okay, so b over 2 is negative 2 over 2 squared. We all know what that number is. It's 1, correct? So we have, so I'm going to go ahead and add it to the right side, negative 2 over 2 squared. So let's go down and simplify a little bit. We have x squared minus 2x plus 1 equals 5/3 plus 1. Okay, now factoring the left side, that's right, it will always come to the point of x plus b over 2. Well, what's my b over 2? Negative 1 squared. Equals, now what's 5/3 plus 1? Again, I'm writing this 1 as 3/3, right? We have 8/3. Sometimes we're going to deal with fractions, and it's okay. All right, so now, we're not too big at the top, so now we need to solve for x. We take the square root of both sides. So x minus 1 equals, and when you take the square root, it's a plus or a minus. The square root of 8 over the square root of 3. It's going to come into play in just a second, because can we leave square roots in the denominator? No. But we're going to keep going and do this all at once. So we're going to add 1. So now we have x equals 1 plus or minus, so we have to this positive 1, plus or minus, because when we take square roots, that's what it is, and I'm going to rationalize all at once if that's okay. Yeah, so when we multiply by the square root of 3 over the square root of 3, we have the square root of 24 over 3, which we could break down even more. Okay, I'm going to put an or here. 1 plus or minus, I believe 4 goes into that, 4 and 6. So 2 on the square root of 6 over 3. Either one of these is correct. Okay, so the one on the right is a little bit more simplified. Okay, they don't have to be perfect. And that's generally why we're going to use completing the square or the quadratic formula. Okay, because they're going to have square roots, and that's just going to happen. Okay, so completing the square, the x squared must be by itself. All right? Perfect. All right, let's do, maybe we'll take the same equation, 3x squared minus 6x minus 5. 3x squared minus 6x minus 5 equals 0. And this time we're going to use our calculator. In our calculator, when we do this, let's see, I think I pulled it up here, yeah. Here we go, y equals, I'm already there, 3x squared minus 6x minus 5. And I want to second calculate, okay? Second calculate is our friend, and then we're going down to number 2, which is a 0, okay? After you go down to number 2, that's the 0. So we're going to do calculate number 2, okay? And then it pulls up left bound. Now the issue is there are 2 zeros most of the time. Could you have a function with more than 2 zeros? Of course you could, and you would have to do it with however many zeros you have. Okay? When does it cross the x-axis? That's how many zeros you have. Okay? When it says left bound, you go to the left of a 0. Okay? So I'm going to use my cursor, and I'm going to go to the left of this 0. So this line here, this part, is to the left of this 0. And then I'm going to hit enter. Okay? And then it says right bound. I'm going to go to the right side of that same 0. Okay, so I'm going to use my cursor to arrow over to the right side of where that 0 is. And I'm going to hit enter. When it says guess, you don't have to move at all. I don't know why I do, but I do. I usually will go back towards where I think it's going to be. It's not going to matter. It doesn't. Okay, so left bound, left of the 0. Right bound to the right of the same 0. Okay, and then your guess, you can go close to the 0 or don't move at all. Okay, now your y value should be 0, correct? Your x value is what we're looking for. Okay, so at this point in time, my x is approximately negative 0.633. Okay, well, that's only one of my zeros. I have to start again. Not all the way putting the equation in, but you have to go back to second trace, which is your calculate button. Do the whole thing over again. I'm going to hit the number 2. Left bound now, I've got to go to this other 0. So I'm going to move my cursor to the right. Sometimes you actually have to find your cursor. Keep hitting right or left. And you can look at your x and y values to show where it's going to be. Okay, left bound, am I to the left of this 0? Yes, I am. Okay, mine puts this little line there. They don't all do that. Okay? Then it says right bound, and I'm going to go to the right of that 0. I'm going to hit enter, and I'm going to hit guess. This time I'm not going to move. See if it's still going to give it to me. It will. My y is 0 when x is approximately 2.63. Okay? No, it doesn't matter how many decimal places you give. Give me a few. I think on the problems I'm giving you today, I specify how many to the nearest hundredth, I think. Um, so that one would have been one short. This one would have been perfect. Okay? Could we go back to that problem that we just had and see if these numbers are correct? So I'm going to quit that. And it was 1 plus, I'm going to see if I can remember this, the square root of 24 in the square root divided by 3 in parentheses. 2.632, I think that's the exact same decimal I had on that last problem we did it in our calculator. Okay, one is an approximation. When we put it in our calculator, the square roots that we did with completing the square are the exact values. It's the square roots. Okay, if I plug in the other one, which I'm just going to go up if you can do this, I love this capability, and just put a minus, because it was a plus or minus, right? Put that same thing in, and look, I get the exact same decimal that was the first one. Perfect. Calculator gives an approximation. Completing the square would give you, or doing the quadratic equation would give you the exact values, meaning the square roots. Okay? All right. I hope that has helped. Writing out a few little step-by-step problems and ways to do it. You have to go through this process. Go through for as many times as you have zeros. Okay, you still have to hit that second trace button or the calculate button. Okay, that's second trace. Being able to use our calculator is a big deal. Okay, the 2 is zeros. Find the zeros. What are you looking for? Okay. All right, are you good? I hope you are. If not, please email me questions. I'll try to explain them. The last one that I want to talk about is factoring. We can all factor when it's really quick and easy. Okay? I know one or two are like, factoring, no. I'll just use completing the square. I'll just use the quadratic formula. I'm going to tell you a little hint. You cannot make it through calculus if you don't know how to factor. Okay? Factoring is a huge deal, just like these other ones are a big deal. Okay? You have to know how to do it. So here we go. I'm going to give you, I don't think it's crazy hard, but it's a number that you have to know, or that you have to use your brain to factor. Now, I'm going to go through my method. If you know the method you learned with Coach King in Algebra 2, use it, please. Okay? There's an AC method that they teach you. It's a method, meaning you go through these steps every time. Okay? Nobody really ever taught me that when I was going through school. So I just always had my guess and check method. Okay? Now, factoring. Root word is factor or factors. Okay? You are looking, when there's numbers that's an A and a C, I personally list all the factors of both of these. Okay? So I'm going to go to 4, and I'm going to list all the factors of 4. Okay? I know 1 times 4, factors. 2 times 2, that's factors. That's all of them. Okay? What about 15? I know 1 times 15. 2 won't go into it. 3 will go into it. 3 times 5. And I'm done because I start with 1 and go until these numbers get to be each other. Okay? And I would list all of them. So, now the biggest piece you have to look at are these pieces right here. Okay, so the first thing you look at is your A and your C to get all your factors. Okay, now this is going to tell me I'm going to subtract. Okay, if that was an addition sign, then I would add. You're right. Okay, so I'm going to subtract factors that will add to a positive 4. Okay, but I have to know which factors to use. Okay, so I'm going to go over here to my list of factors. I'm going to erase really quick this little arrow because I don't want that there. Okay, so I start checking. What if I do the first 2 factors? So I'm going to look at those 2 and say, I'm going to multiply 4 times 1. I'm going to get 4. 1 times 15, I'm going to get 15. If I subtract those in either order, 15 minus 4, that's 11. That is not a positive 4. Okay? Now, I could try 4 times 15 and 1 times 1. My logic brain says, I don't think that's going to give me a positive 4 when I subtract 60 minus 1. Okay? So it can't be this that I've circled first. It can't be these 2 together. Okay? So maybe I check these 2. Okay? So I'm going to multiply. I could do 4 times 5 is 20. 1 times 3 is 3. That's going to give me 17, not a positive 4. So neither one of those are working. What about 4 times 3 is 12. 1 times 5 is 5. That's 7. Not 4. So it can't be this combination either. Okay? So I can go ahead and mark out it can't be the 1 times 4 factors. Okay? Because I've tried that with both of these pieces. And they don't work. Okay? So I'm going to move on, and I know it has to be a 2 times 2. Okay? But this is the one I've got to take. 2 times 1 is 2. 2 times 15 is 30. 30 minus 2 is not going to give me 4. Okay? That was this method. Going from 2 times 2 to 1 and 15. And changing that order doesn't help. So it can't be the 1 and 15. So now I know it must be these 2 sets of factors. Okay? Now, this is a long method until you start to really get it. Okay? The first few times you do it, it's kind of like, oh, I've got to go through all of these. You really don't. Once your brain, I think you guys can get it pretty quick, to say, hey, it can't be any of those because that's going to be way too much. And you don't have to really try all of these. Okay? But now I know it has to be a 2 and a 3. So 3 times 2 is 6. And 2 times 5 is 10. 10 minus 6 is 4. So now I need a positive 10, or let me write it like this, a positive 10 and a negative 6. And that's going to give me the 4. Well, I probably need to know what I did with that. I did a 2 times 5 to give me the 10. And I did a 2 times 3 to give me 6. And which one has to be negative? One of these 2 times 3. 2 times 3 must be negative to give me a negative 6. Okay? So, when I go back up here, when I'm factoring, I draw my parentheses first. What times what is going to give me 4x squared? Well, I know it has to be 2 times 2. So I do a 2x times 2x because they're in opposite parentheses. Okay? Then I know the 2 has to be times a 5. Well, now this one is kind of cheating because they're both 2's, and it doesn't really matter which one goes in which parentheses. So I'm just going to put it here because here we have a 2 times 5. And then with this one, we would have a 2 times 3 when you're doing outside and inside. Now, which one did I say had to be negative? Yeah, the 6. So when I do this 2 times 3, it must be negative. And my 5 times 2 must be positive. That helps me put the plus and the minus in the right spot. Okay? And I don't know, I'm pretty sure I've said this maybe 5,000 times in this year that we've been in school, the 3 quarters. If I ever factor, because of the method that I use, I guess, and then I always check. So I go back and check. My first FOIL, remember FOIL, my first 2x times 2x, does that give me 4x squared? Of course it does. I hope that this part should not take you long. 5 times negative 3, does that give me my negative 15 at the end? Yes, it does. Now the piece that I write down generally is my inside and outside, my O and my I. My inside, 5 times 2x gives me 10x. 2x times negative 3 gives me negative 6x. When I add those, do I get the middle piece of a 4x? And I do. Okay? That is my long method of guess and check for factoring. If you know a better way, if you know a different way, use it. If you can't remember it, I don't know. Go with my method or figure out another one. Okay? Because they've tried to teach me the other methods, and I just looked at Coach King and was like, yeah, no, I'm going to stick with my own. Okay? Because once you get set in your ways, you have to just keep going. All right, so here we go. I have 2x plus 5 times 2x minus 3, and that equals 0. Now, how do we solve for x? When it says solve, I want x equals. You can't just factor it and be done. Okay, you have to set each piece equal to 0. And then you solve 2 separate problems. 2x plus 5 equals 0. You're going to subtract 5 and then divide by 2. I think you probably can do that pretty quick. Divide by 2, x equals negative 5 halves. Then we're going to add 3. 2x equals 3. Divide by 2, x equals 3 halves. So we have our 2 answers. Okay? Whew, I feel like we probably should do another one. Okay? I don't know about you, but I'm going to write one down really quick. And I always start with a factored piece and then go backwards, just so you know. So here we go. Let's do 6x squared. Okay, here we go. Sorry, I did not have another one planned, but we're going to do one more. If you are given 6x squared minus 17x plus 10 equals 0, can you factor this problem? All right. My method, I'm going, and I'm not going to take quite as long this time. I'm going to go a little quicker. So I'm just showing you that it doesn't have to take a long time. So my factors of 6 are 1 times 6, 2 times 3, that's it. 10, 1 times 10, 2 times 5, and that's it. Okay? And it's really nice when there's not a long list. I know Coach King, I do remember AC method is you multiply 6 times 10 and get 60. And then you have to list all the factors of 60. There's a lot more than 4, I promise. Okay? So that's what part of the reason I like mine better. You don't have to list lots of extra factors if you don't have to. Okay? In this, I'm adding factors to equal a negative 17. So what does that mean? Everything has to be negative. A negative times a negative will give me a positive here. But I'm still adding the factors. Okay? So I go to the side. I check the first, kind of check the first every time. Again, I can do this in my head a little quicker, which I know it's not going to be 60 plus 1, that's 61. 6 times 1 is 6, 1 times 10, oh, that gives me 16. So close, but it's still not there, right? So it can't be this. What about, let's change colors as I do this. Oh, that's a good idea. 1 times 6 and 2 times 5. What about, I could do 6 times 5, that's going to be 30, plus 2, that's 32. Not going to do that. What 6 times 2 is 12. 1 times 5 is 5. Is 12 plus 5 equal to 17? Yes, it is. All of a sudden, I got it. Okay? Really on the second one that I tried. So I need 6 times 2 plus 1 times 5. Okay, so that gives me my 12, and that gives me my 5. And they all both have to be negative, right? Because I want it to be a negative 17. So this needs to be negative, and this needs to be negative. Okay? So let's go over here. So I need 6 times 2. So in my parentheses, that's for some reason I draw first. I need a 6x and a 1x. Okay? But I need that 6 to be times a 2. And I need the 1 to be times a 5. Okay? Does that make sense? And then they both have to be negative. All right, I have something down that's factored. Now I'm going back to check. 6x times x gives me 6x squared. Negative 5 times negative 2 gives me a positive 10. Okay, those I shouldn't have to write down. Those should be pretty quick. But I always check those first. Because if that doesn't work, that has nothing to do with the middle. You can't make the middle work if those first, this 6x and that positive 10 aren't there. Okay? Next, let's try the inside. So negative 5 times x is negative 5x. And then the outside, 6x times negative 2 gives me a negative 12x. And when I add those two together, I get a negative 17x, and that is my middle term. Okay? It works. I have factored correctly. You should never get a factoring problem wrong because you can always check it. Okay? So now we have factored 6x minus 5 times x minus 2 equals 0. Now we're going to solve. 6x minus 5 equals 0. X minus 2 equals 0. Starting with the left one, I'm going to add 5 to both sides and then divide by 6. That's 1x equals. Here, just add 2. X equals 2. You're done. Okay? Factoring is wonderful. I've just got 8 problems for you, and I probably already uploaded it by the time you're watching this. So, have fun. Good luck. Fun. Quadratics. They can be fun, I promise. All right, have a great weekend, and I will talk to you later. Bye.